What's good, math family? Back with another Algebra 1 Regents Exam review. We're focusing on how to properly solve open-end response questions. Please make sure you check out the description box. We have the other Regents Exam reviews as well as a complete test for you guys to practice on. Let's get started. In the first example, they give us a system of quadratic and linear equation, and we could solve this by using substitution. So what we're going to do is set both of these equations equal to each other, and then we're going to see if we could factor or use the quadratic equation to determine what the x is. So after we start combining, we're going to have x squared minus 9x plus 12 is equal to negative 6. And now we're going to add 6 so that we could set this quadratic equation equal to 0. Once we do that, family, this is the quadratic equation that we want to factor. And when we factor it, what we're going to get is x minus 6 times x minus 3 is equal to 0. So when we set our factors equal to 0, first answer choice is x is equal to positive 6. And the second answer choice is going to be x is equal to positive 3. Now, just remember that this is not the complete answer. What we're looking for are two ordered pairs where the parabola and the line intersect. So what we need to do now is take those x's, plug them back into one of the equations and determine the y. Let's use the easier equation, which is the linear equation. So when I substitute, we're going to get y is equal to 12 minus 6. So y is equal to 6. So my first ordered pair is going to be 6, 6. This is the first point of intersection. Then the second point of intersection, when we go back and substitute, we're going to have y is equal to 6 minus 6, meaning y is equal to 0. So my second ordered pair would be 3, 0. So if they give you a system of quadratic and linear system, this is how you would solve it algebraically. You could use substitution, set the equations equal to each other, and then solve. In the next example, family, I want you to understand that this is the same type of problem as problem number 1. The only difference is that we're going to solve this one by graphing rather than algebraically. So the first thing I would tell us to do is let's start off by graphing the easier function, which is the linear one. So we know that the y-intercept is -1. And if we use our slope of 1 over 1, we could find other points so that we could create a straight line. Once we do that, this is what our linear function should look like. Now that we've graphed the linear function, we could focus on the quadratic function. And typically with the quadratic function, family, the first point we're going to want to plot will be the vertex. So to find the vertex is a two-part process. We're going to find the x, which will use the opposite of b over 2a. So x is equal to the opposite of b, which is -3, over 2 times a. We know a is 1. So the x-coordinate for the vertex is 3 over 2. Now that we have that information, we're going to plug it back in to get the y. So y is equal to 3 over 2 squared minus 3 times 3 over 2 minus 6. When we simplify, this is what we'll have. Now the issue here is that we have fractions and we can't combine them unless they have a common denominator. So we're going to come up with equivalent fractions that have the same denominator. So 9 over 2 turns into 18 over 4, and -6 is going to now be 24 over 4. When we combine these fractions, we're going to get y is equal to -33 over 4. So the first point we're going to plot for the vertex is 3 over 2, -33 over 4. So when I go to my graph and I plot this, it should be, let's see, vertex should be right here where you see this red dot. Now before we find other points, let's just erase so we can get some more space. So as we continue, family, I want you guys to understand that we at least need two more points to create this parabola. And the reason why I say only 2 points is if you understand the axis of symmetry, you know that it cuts the parabola in half. And I'm going to explain why this is important. So when x is 0 and we plug it into the quadratic function, the y is going to be -6. This also represents the y-intercept. Now, if we focus on the x values for the vertex, which is 1.5, and the y-intercept, which is 0, we notice that we went over to the left 1.5 spaces. So if I go to the right, the same distance, 1.5, my x is going to be 3, and that x is going to share the same y coordinate as the y-intercept. So I can make a point at 3, -6. So what we could do now is we could pick our next x, and let's say that our x is going to be equal to -1. Now, when x is -1, that means from the vertex, we went over 2.5 spaces on the x-axis to the left. If I go over 2.5 spaces to the right on the x-axis, that means x would be equal to 4. So when x is -1 and x is 4, they're going to share the same y values. So let's plug this in and let's simplify. So we have y is equal to -1 squared minus 3 times -1 minus 6. So y is equal to 1 plus 3 minus 6. So we're going to get y is equal to -2. So we know that when x is -1, y value is going to be -2. And the same thing for when x is 4, the y value is going to be -2. So these are the next 2 points that we could plot on our graph. So at -1, -2, we notice that this point is also on the linear function. So that's one point of intersection. And then when we go over to 4, we have -2. Now, the next x that I would tell you, family, to go and focus on is when x is equal to -2. Now, when x is -2, that means from the vertex, we moved to the left 3.5 spaces. So if we move from the vertex 3.5 spaces in the opposite direction to the right, that means x is going to be 5. So these two x values share the same y coordinate. So let's plug it in and determine what that is. So y is equal to -2 squared minus 3 times -2 minus 6. So when we simplify, we're going to get y is equal to 10 minus 6, which is 4. So our ordered pairs are going to be -2, 4. That's the first one. And then 5, 4. So when I go to plot this, we're going to plot the first one at -2, 4, which is right here. And the second one at 5, 4, which is right here. And what we notice is that we have another point of intersection at 5, 4. So when I draw a line through my parabola, this is what the sketch should look like. And we're interested in these 2 points that you see me highlighting. So when they ask us to state the coordinates of all solutions, the answer would be -1, -2, and then 5, 4. So when it comes to solving quadratic and linear systems of equations, family, whether it's algebraically or graphically, this is how you would do it. And we're going to go on to our next example. In our next example, family, we're dealing with graphing and shading systems of linear inequalities. And I'm going to tell you guys that we should try to put it in the same format as y is equal to mx plus b. The equal sign we know will be replaced with a inequality. So let's say we looked at the simple equation of y minus x is greater than 1. So if I put that into slope-intercept form, we're just going to add x, and we're going to have y is greater than x plus 1. So this is the first inequality that we want to graph. So when we go to graph this, y-intercept, right, we know is at +1, and we can use our rise over run of 1 to find more points. Now, to make sure that we get this correct on an open response exam, we have to make sure that we understand that this is supposed to be a dashed line. If you draw a solid line, you're going to get partial points, family. So please don't make this mistake, okay? They're betting on you guys getting the line correct, but making the incorrect shading. And when we look at this, this says that y is greater than x plus 1. So typically with a graph like this, that means we should be shading above this line. And I like to just use arrows so I just know which direction I should be shading. Now when we go back to the other inequality, 3y plus 2x is less than or equal to 15. First step is going to be subtract our 2x. So 3y is less than or equal to negative 2x plus 15. And now we're going to divide by 3. So y is less than or equal to negative 2 over 3x plus 5. So this is the second inequality we're going to graph and shade. So we know the y-intercept is 5. And this is going to be a solid line because of the or equal to. And we can use our slope 2 over 3 to find another point. So I could go down 2 over 3 to get a point right here. And then I could go in the opposite direction to get another point right here. So now the difference here is that this line is going to be solid. So when we connect this line, I'm going to draw a straight line, and this is what it should look like. Now it tells us that y is less than or equal to. So typically that's going to be under this line. And I always tell students use 0, 0. And what we're looking for the solution is where the two arrows meet. If we look, now let's switch to blue. If we look in this area right here, we only have green arrows. If we look over here, this only satisfies the red arrows. But when we look in this area that I'm shading with the yellow, we notice that we have green arrows and red arrows pointing towards each other. So if they told you to label it S, this would be the solution. And if they ask us to state the coordinates of a point in the solution of the systems, this is very easy. All you have to do is pick any point within this area that satisfies both equations. So we could pick the point -4, 4. And if they ask us to justify the answer, all you have to say is that this point satisfies both the inequalities. And because we have time, let me show you what I mean. So let's plug it into the first equation. So we're saying that the y-coordinate 4 is greater than -4 plus 1. So 4 is greater than -3. True statement. We go to the second inequality, plug it in. +4, and remember this is coming from the ordered pair, is less than or equal to -2 over 3 times -4 plus 5. So 4 is less than or equal to, let's see, this is going to be +8 over 3 plus 5. And when we simplify that fraction and add it to 5, that is also going to be a true statement. So this is what we mean when we say that that point satisfies both inequalities. In the next example, we're dealing with quadratic functions. And even though this does not have a C term, the process is the same for graphing it. So we're going to start off with finding the vertex. So we're talking about the opposite of b over 2a. So x is equal to the opposite of 48 all over 2 times a, which is -16. We're going to get a positive 48 over 16. When we reduce this fraction, the answer choice that we're going to get is going to be 1.5. So this is the x value. So let's plug this back in. H of t is equal to negative 16 times 1.5 squared plus 48 times 1.5. When we simplify this and put this into the calculator, the y value is going to be 36. So my vertex is going to be 1.5, 36. So when we go to our graph, and let's switch colors real quick. That point is going to be right here. Now, real quick, family, because of the question, it says how many seconds does it take for the ball to hit the ground? What I would tell you to do is to pick one, maybe 2 points. And this is why. If we pick a whole number like 0 and 1, those are easy numbers to plug into this function and work with. So let's erase first so I could show you exactly what I mean. So when x is 0, and we look at that compared to the x coordinate of the vertex, we went over 1.5 to the left. So if we go over the same distance on the x-axis to the right, x is going to be equal to 3. So these two x values share the same y coordinate. When I plug 0 into this function, the result that I'm going to get is h of t is equal to 0. So when x is 0, y is also 0, and then when x is 3, y is also 0. So these are 2 points that I could plug in already just by understanding the relationship between points and the axis of symmetry. Now the next 2 points that we could pick are when x is equal to 1. So because we went half a space to the left, right, 1.5 to 1, if I go half a space to the right, the other side, x is going to be equal to 2. So these two x values are going to share the same y coordinate. So let's do when x is 1 because that's a little bit easier to work with. So h of t is equal to negative 16 times 1 squared plus 48 times 1. When we simplify, we're going to have negative 16 plus 48. When we combine these two together, h of t is going to be equal to 32. So the ordered pairs we're plotting are 132, that's the first one, and then 232. So let's also plot these as well. So now all we need to do is just draw a line through these points for our parabola. And as a sketch, this is what the parabola should look like. I would tell you guys, don't worry about trying to plug in 0.5 or 2.5 into this function. It's going to be a little bit more challenging to work with. Now, when we focus on the questions below, first question says, what is the maximum height in feet that the golf ball reaches in the air? Well, that's represented by the vertex, right? And if we look at the y-axis, the measurement is feet, and we should know that the answer is 36 feet. Please make sure you include the units. They will take points off if you just put 36 by itself. Now, the second question says, how many seconds does it take the golf ball to hit the ground? Well, think about these 2 points at the bottom. At 0 seconds, we did not hit the ball. Then once we hit the ball, it went all the way up to reach its highest point, which is the vertex at 1.5 seconds. And then from there, it's on its way back down to the ground and it hits the ground at 3 seconds. So our answer for this second problem, oops, let's switch back to red, is going to be 3 seconds. And yes, always include the units. We have another problem on solving and shading systems of linear inequalities. But instead of switching this over to slope-intercept form, let's graph this by standard form. So if we made y 0, we would have 2x is greater than 4. So we have x is greater than 2. So when we look at the x-intercept, here goes the first one. When we go back and repeat this process again, we have negative y is greater than 4. Y can't be negative when it's by itself. So we made that positive, 4 becomes negative, and our inequality sign flips. So we know the y-intercept is going to be negative 4. And now we could draw a line through it, and just be mindful, family, that because of the greater than or less than sign, both of these inequalities are going to be dashed lines. And the reason why this is important is because if any of the points fall on the actual line, it will not be a solution. Now, what I would tell you guys with determining which side to shade, let's just pick the point 0, 0. So when we plug that in, 2 times 0, 0, y is 0, and this is greater than 4. So is 0 greater than 4? No, this is not correct. So we're going to shade towards the side that does not have that point 0, 0. So this is why you see me putting these arrows on this side of the inequality. Now we're going to go back and we're going to do the same thing for the other inequality. So we have x plus 3y is greater than 6. So when y is 0, we have x is greater than 6 left over. So when we go over to the x-axis, here goes the second point. That's at 6. Then we go back, and now what we're going to do is make the x 0. So now we have 3y is greater than 6. We're going to divide. So we have y is greater than 2. So on the y-axis, here goes the intercept so that we can now connect a line through the points. All right, perfect. Now, real quick, family, let's make this red line just a little bit longer so it covers the whole graph. So now we go back and we're trying to determine which side do we shade. And I'm going to tell you guys again, pick the point 0, 0. So 0 plus 0 is greater than 6. This is a false statement. So when we think about this, we're not going to shade under the line where 0, 0 is. We're going to shade above the line away from 0, 0. And if you look, we could see where the arrows meet. And they meet right here. This is where both the red and the green arrows meet. And this would basically be the solution. Now, what they ask us for is if the point 4, 2, is this a solution to the systems? And that point, let's use the color blue, is going to be right here. And family, I want to tell you guys that yes, this is a solution to both of the inequalities because if we plug it in, it's going to be a true statement. And 2, it's in the shaded area. As long as it's in the shaded area, it's a solution. Now, if it fall down the line, like this second blue dot that I'm making, it would only satisfy the inequality in green, but not the one in red. So please understand what they are asking you when they ask you this question, okay? But the answer is yes.